Hi everyone, my name is Hannah Sargent and I am a planetary scientist at the Open University, based here in Milton Keynes. And in my research, I look at how we can find and access water on the moon so that one day we could potentially use that water to support a moon base. Now tonight, I'm going to be walking you through some software and some websites that you can use that are free to use so that you yourself can explore the moon from the comfort of your own home. And this is really important, especially right now, as we can't always get out and access the kind of facilities or events that we'd like to. But hopefully this is a really nice way for you to keep exploring, even while sat on your sofa in your pyjamas. So I'm going to talk you through two programs. One is Google Moon, which is a subset of Google Earth, and another one is called LROC Quick Map. Okay, so to begin with, I'm going to be looking at Google Earth and an aspect of that called Google Moon. Now, many of you might be familiar with Google Earth. You can access it on your internet browser, or you can actually download for free something called Google Earth Pro, which is what I'm going to be using today. I just find it easier to work with. So if you go to this is just the opening screen of Google Earth Pro. And if you look to the top bar here, you might notice there's a small icon in the shape of a planet. And if you click on that, you can scroll down to Moon, and that will take you to Google Moon. Now, Google Moon was created about 10 years ago now to celebrate the 40th anniversary of the Apollo 11 landings. So Google Moon uses imagery from Clementine, and this took images of the moon in orbit, and that's why we have these stripy images, because as the satellite was moving up and around and across the surface of the moon, and around the moon, the lighting would have changed slightly throughout the days, and that's why you have these different sort of stripy artifacts of these images. And this is the face of the moon that you might be used to seeing. So this side of the moon, called the near side, is always facing Earth. So when you look up into the night sky, this is the side of the moon that we always see. So you might be used to seeing some darker areas and some lighter areas. So the lighter areas, we call them the highlands. These are older materials formed when the moon initially, when it was sort of molten rock, when it was initially cooled down. This is some of the first material to cool. But then in the lower areas, these actually flooded with lava in these oceans of lava, and forming this basaltic darker rock. And actually we call them the mare regions, which translates to seas, because ancient astronomers actually thought that these were seas on the moon. But what's interesting, if we turn the moon around, this is what we call the far side of the moon. So very few people will have seen this with their own eyes. Only the astronauts that have orbited around the moon will have seen this side of the moon themselves. And you can see it's very different actually. It's a lot of lighter material, so a lot of highlands on the far side of the moon. And it's not called the dark side, so that's a common misconception, because the far side of the moon also sees sunlight, and that's why we were able to take these lovely images across the surface of the moon. Okay, so let's scroll back around here also. Okay, now one of the main reasons I like to use Google Moon is because it's good for looking back in history and human exploration, particularly during the Apollo missions and so on. So for example, let's take a look at some historic maps. So on the left hand side down here, if I click on historic maps, so these are maps that were created around the time of the Apollo missions to help support the missions. So we have some geologic charts here, and they're split up, I believe they're called quadrangles. So each map would have, just to break it down into sort of bite-sized chunks, and if you click on it and zoom in, oh sorry, see if I can click on one of these. There we go. Explore this map. So you can actually look at the original map that was created, and if you use your scroll wheel on your mouse, I would suggest using a mouse for these. I just find it easier to work with. So these are some pretty old maps here. This one was created in 1960, in fact. So this would have been using images of the moon, and they would have looked at the different shades on the surface and the shapes that they could see and try and determine what sort of materials they are. And again, you can look further at those over there. But more importantly, these maps are used to help determine safe landing sites as well. So you can use the geologic maps to help find areas of particular interest where we might want to collect some samples to bring back and study here on Earth. We also have topographic charts. So these are charts that tell you about how steep slopes are and what the terrain is like. And this is helpful for finding your safe landing site, because you want to land somewhere nice and flat. It's really hard to pinpoint an exact place where you're going to land. So you need to have a big, wide open space, a flat space that is safe for the astronauts to land in. Okay, so I'll close off of the historic chart. Now, you might also notice these small red flags, and those little red flags are human artifacts. So these are things on the moon that were created by humans. And we also have the Apollo mission. So what I'm going to do, I'm going to take us in to Apollo 11. So I'm just going to click on the Apollo 11 badge here, and it will take us all the way in. So you don't need to know where exactly the missions went, because Google Moon will do it for you. Okay, so what we've got here is the landing site of Apollo 11. Overlaid on top is one of the maps that was created showing where the astronauts went. So you can see they didn't explore too far away from their landing site. Just a couple of little craters nearby, nice and close to their lander. So if you zoom in, so I'm just going to scroll in here, you can see they've superimposed the lander. Let's see if I can turn around. So we have our lander here, we have a flag here, and you can see there's lots of little things you can click on. So there are some YouTube videos that you can go and check out, of videos that were recorded on the surface. We can see exactly where things were placed. So we have SWC, this is our solar wind collector. And we can also check out some cool images that were taken on the surface. So if I go the view from Little West Crater, fly to this photo. So this was taken by one of the astronauts. You can see we've got the lander here. There's our solar wind collector. This is one of the science experiments. Got the nice shadow of the astronaut there. And this is one of the craters near to the landing site. Okay, so if I zoom out, so there's lots to explore here, that lots of like cool little artifacts to go and check out. But now I want to take us on to Apollo 17. So this is the last mission from the Apollo era. So these are going to be the last humans on the moon, and we can see how different the missions were. So I'm going to fly us in to the Apollo 17 landing site. Okay, and you can see, so we've got superimposed here the route that the astronauts took, and so they had a rover this time so they could go and drive around and explore, and you can see they explored much further away from their landing site than they did in the first mission to the moon in Apollo 11. Now what I'm going to do, one of the cool features they have here, they have some guided tours from the astronauts, so you can listen to Buzz Aldrin talk about Apollo 11. I'm going to give you a quick snippet of the Harrison Schmitt guided tour. So Harrison Schmitt was the only scientist to have ever gone to the moon. Everyone else, they were, your pilots, the standard astronaut of the day. Whereas having a scientist, particularly a geologist, is really helpful because they can pinpoint areas of interest or particular samples on the surface with their eyes that we might not have thought about or identified from orbital images. So let's have a quick listen to this tour.
I'm Jack, Apollo 7 flew on the Apollo 17 mission in December of 1972. The crew of Apollo 17 was an aggregate of two backup crews, Apollo 14 and 15. I replaced Joe Engle on that crew, and Gene Cernan would be the commander, and Ron Evans was going to continue as the command module pilot. Gene Cernan got out of the spacecraft first, and I followed him fairly quickly afterwards. We were in a valley deeper than the Grand Canyon of the Colorado. The mountains on either side were 2,100 meters, or about 7,000 feet high. The sun was as brilliant as any sun that you can imagine. Even more impressive was the Earth, which was hanging over one of the mountains and stayed hanging over that mountain, the South Massif. And that was really a magnificent sight for me, and that's what I remember as being sort of my first real impressions of the Valley of Taurus Littrow.
Okay, so there's plenty more for you to check out there. I'm just going to exit this ground level view, and I want to take us to one of the places they visited. So they visited the base of this mountain here, the South Massif. And you can see that the images, the problem with the Clementine images is that they are outdated now. We do have much more improved imagery, so there isn't a lot of resolution here. But I do like that they have superimposed some images taken at these locations that you can go and zoom in on. Let's see. Fly into this photo here. So this is at the base of the North Massif. There's another of the crew members there, likely taking some samples. Oh no, sorry, taking photos and images by the looks of things, and videos. There's the rover down there. You can see their footsteps in the sand, well, in the soil, shall I say. Okay, so I'm just going to zoom out of this now. So what I'd like to do next is look at this same location, but using a different piece of software or program that you can all have access to. Okay, so next I want to take you to use another piece of free software. Well, it's a program that is available online, and it's called LROC Quick Map. So if you search into your search bar, LROC Quick Map, this is what should come up. Okay, so LROC Quick Map is actually, it was designed for the Lunar Reconnaissance Orbiter camera team. So the Lunar Reconnaissance Orbiter is actually in orbit still around the moon, taking lots of images using all of the different cameras, and also obtaining lots of different information using other instruments they have on board. But the team wanted to be able to see their images as one on the moon and look at kind of like how they refer to each other and kind of like the context within the whole moon. And so they worked with ACT to develop this program, and most importantly, they made it free to use for everyone, which has been great for people like me I've actually used this in previous research, but even just for lunar enthusiasts who want to go and explore the moon and looking at some of the most recent images and data that we have available. So first off, it shows you this 2D version of the moon, but it can see it's beautiful and crisp. I find a lot easier to look at than the Google Moon version, and you can actually switch to 3D and take a look again all over the moon, and it is just, well, I find stunning anyway. So I'm going to return us back to the home view, and I want to fly us in to the Apollo 17 landing site again. So it's actually been around 48 years, almost I think to the week, since the Apollo 17 mission, which is one of the reasons why I'm really interested in taking a look at this site again. And we can take a look at this site. So first off, how do we find it? It can be a bit overwhelming, so there are a lot of different options here of layers of things to search for, but I'll try and walk you through it gently. So if we go to overlays, and we can click on anthropogenic features. That's just a fancy way of saying human artifacts. So things that humans have created that are now on the moon, whether that's landers or rovers or debris or whatever it is. And if you click on the text underneath, you should see there's a lot more information and directions of where to find more information. And we can actually narrow down the particular feature that we're interested in. So I'm going to look for Apollo 17, but you'll see that there are lots of other missions highlighted here from lots of different countries as well, which is really important. So first off, I'm just going to take a look at Apollo 17. So I want to head to the lunar module. It takes us right in, which is perfect. Okay, so I just want to check. Okay, so I'm currently in 3D, but for what I'm about to do, I want to be just on the near side projection. Okay, so it doesn't work as well with 3D. And what I want to do, if I zoom in here, okay, I want to now draw a shape around the Apollo 17 landing site and search for the best high resolution images we can find. So I'm going to draw a polygon, just a shape around here, double click to finish, and I'm going to search for, again, lots of different data sets you could look at, but I'm interested in the narrow angle camera. So this is the highest resolution images that we can look at, but it will give you a lot of, it will just kind of, your screen will freak out. So we want to filter it down. There are lots of things you can look at, but for what we're doing here, the only thing of importance is resolution. So you want to have the smallest amount of space per pixel. So I want to go less than a meter per pixel. Okay, and I'll click on the first one that comes up and it will load, and look at that. So if I zoom in, I think this is the maximum I can zoom in. So this here is the lander, so it's still there. What's left of the lander. On the moon, we've got the little shadow created from the lander, and then you can see all of these marks from where the crew in their rover went and explored. So these are images that have been taken from the Lunar Reconnaissance Orbiter every time it flies over the Apollo 17 landing site. So these are taken at different times of day. So no claims of we haven't landed on the moon before here. So we've got all of our lovely images here from the Apollo 17 landing site, lovely and crisp and really beautiful to look at. But next I want to take us back to, so if you remember, we were looking at, or the team went to explore the North Massif, which is this area here. So they explored up to this region. And if we zoom in, even with the wide angle camera, which is what these base images are here, the resolution is so incredible, even compared to the Clementine images. You can see these boulder tracks of boulders that have rolled down the slopes of the moon, and these are created when rock is broken off or ejected from craters, from impacts, meteorites striking the surface and so on. And so quite often we find these boulder tracks down slopes on the moon. And the Apollo 17 crew actually went and visited one of these boulder tracks. And what I'll do is, what I'll do is I'll show you here. I'll try and superimpose it. Oh, go on, I'll have a look. Brief look at this particular boulder. NAC images. Let's go to high resolution. There we go. So you can see that this boulder was actually broken in half. It stopped rolling and it had fractured and crumbled. And the crew visited this site, and you can see these little dark squiggles right next to the boulder, and this is where the crew were walking around and taking pictures, and the rover actually pulled up quite close, I believe. So we actually have a picture of the crew that was taken right next to this boulder. And in the work that I've been doing in the past, we've actually been looking at boulder tracks on the moon, and we can use these images. So we've used QuickMap to measure the size of the boulders, the size of the tracks and the shadows within the tracks to try and understand how deep they are. And we can use that to better understand how soft the surface material is. And if we can do that at locations that we haven't visited on the moon before, and make sure that any rovers that we send there aren't just going to sink into the soil irretrievably. So it's really important that we can use these images for free to do some really important science. Okay, so let's exit out of here. Let's delete these. So now I just want to show you one of the features of QuickMap that I really enjoy, and that is looking at the moon in 3D. Now, because they have some of the highest resolution images and the most up-to-date topography maps, so that, again, I mentioned earlier, they are, the slopes that you see on the moon, on the hills and in the craters. And what they've done is they've overlaid them together. So in 3D mode, you can explore them with sort of an astronaut's viewpoint. So if we just briefly switch our projection to 3D mode, it can take some time for the images to load, because it's a lot of information that it's now handling. Let's see. There we go. So you can zoom in and out, but if you hold down the mouse wheel, you can take a look. So this is what the astronauts would have seen as they would have descended towards the surface of the moon. So as they were flying in, they would have had to make sure that they landed safely in a nice flat area. And you can zoom in and take a look. So if you were to explore at the base of the mountains, this is what you would see. And looking behind you over here, and eventually the images to catch up. And this is a really useful tool if this sort of program can be used to help train astronauts as they plan their routes, as they go and collect samples and do experiments on the moon. Okay, so now I'm just going to exit out of this. So some of you might be aware that very recently, let's go back to the 3D view. So very recently there was a Chinese mission to the moon, and this will be only the third country to get samples from the moon and bring them home again. So this is going to be a robotic mission. It's the Chang'e 5 mission. And it's heading to a northwest region of the moon, somewhere up here, and they're going to be collecting samples and bringing them home. And one of the reasons why they're interested in this particular area is because it's long been thought that volcanism on the moon, so volcanic activity, kind of died out quite early on in the moon's history. But there's reason to believe that there's some much younger material here, suggesting that volcanic activity perhaps went on even longer than we originally thought, and that opens up a lot of questions for the scientists trying to understand the moon's formation and what's been going on in the history of the moon. So that's one really exciting thing about the mission. But also, by sending missions to the moon and getting them safely home again, that's one step closer to sending humans to the moon and getting them safely home again. So a lot of this work is building up to having humans on the moon once again, but hopefully for a longer period of time. Now, next up, I want to take us to the South Pole of the moon, because this is where the future of lunar exploration is really looking like it's going to be. So in the South Pole of the moon, there's reason to believe, if it's on 3D it gets a bit messy, there's reason to believe that there's frozen water there, and that is going to be a very critical resource. I will talk a little bit more about that in a moment. But first off, I want to take us to Schrödinger crater. So Schrödinger crater, let's go to a South Pole projection. So Schrödinger crater is in a really interesting location, which makes it an interesting target for future missions, for both science and exploration. Now, Schrödinger crater lies near to what we call the South Pole Aitken Basin, which is in this region down here. And in the South Pole Aitken Basin, there was a giant impact that released material from deep within the moon and ejected it onto the surface, including probably in Schrödinger crater. So if we can sample some of those materials, we can learn about what the interior of the moon is made of. Now, Schrödinger crater itself is also quite a large crater, so big that it has an inner ring. So you'll see these sort of inner rings form in quite large craters. And this is material, again, that has been kind of risen up from an impact. And we can sample that and learn more about the types of materials found on the moon. But also, you might have noticed this quite dark area here, and this is what we call a pyroclastic vent. And pyroclastic vents are quite cool because these are vents where hot magma has basically exploded out of this vent and it's instantly cooled into a glass. But if we can sample that glass, trapped inside could be some of the gases that is found in the material deeper within the moon. So we don't have to dig into the moon, we can just target these areas and it will tell us a lot about places that we can't access much deeper down. And one final thing of interest about Schrödinger is that because it's so close to the South Pole, the sun is very low in the sky, and when that happens you get quite large shadows, and in some places, no matter what time of day or time of year, there are shadows that are, well, they're constantly shadowed. There are areas that are constantly dark and cold, and what that means is that they could trap water ice because it will just stick there and instantly freeze, whereas anywhere else on the moon, water will instantly vaporize. So there are some areas, we call them permanently shadowed regions or PSRs, and these are a massive target for the future of lunar exploration. So Schrödinger could be a really interesting target, but it's still a bit far out from directly over the South Pole, and I'll kind of show you a bit more about that now. So if I go to layers, I want to look at permanently shadowed regions. So this is highlighted areas that I was just mentioning in permanent shadow. But these are, if I look at some of the information, 10 kilometers squared or larger. So these are massive permanently shadowed regions. So there are going to be some in Schrödinger as well. But there could perhaps be better targets in these larger areas here. So these kind of orange outlines were calculated looking at the slopes of the craters and the angle of the sun in the sky, and basically figuring out where there were areas that wouldn't get to see sunlight. But we can actually look at lots of different data sets from different missions and see why we're so confident that there's going to be water ice in these places. So there are areas that we know are going to be in shadow. Okay, so that's the first step. But next we can look at the diviner instrument. So this is looking at temperatures. So if I look at the minimum temperature, okay, and overlay that, what I'm just going to do, I'm just going to blend it in a bit so we can see. And you'll see that in these areas that we think are in permanent shadow, they tend to be the places that are really cold. In fact, some of these places are as low as 30 Kelvin. That's around minus 240 degrees C. And this is some of the coldest places in the solar system. So even though we can't have liquid water on the moon because there's no atmosphere to keep it, to stop it from vaporizing, any water that is brought, if it reaches one of these cold traps, it will instantly stick there. So over millions, billions of years, these could be places that have collected quite a lot of water that we could potentially harvest. So next up, let's take a look at, I think it's the LEND instrument. So this is using a neutron detector. It was able to detect hydrogen that we think is in the form of water. So the resolution isn't great. Let me just turn this down. But you can see over particularly these big PSRs, there seems to be quite an increase in the amount of hydrogen, which is telling us that there's probably water or surface water in these regions. So this is why over the next few years you might be seeing a lot of missions heading to the South Pole, because what we want to do is prove, because we haven't actually been there yet, is sample it and see if there is actually water there. And actually that's some of the missions that I'm involved in. So the PROSPER instrument is being developed at the Open University, and it's going to be landing near to one of these, hopefully near to one of these permanently shadowed regions, and drilling down into the surface and seeing how much water we think we can find there. And hopefully you'll start to see, maybe in our lifetime, permanent moon bases on the moon near to some of these PSRs, hopefully again in a flat area, because we need to be nice and safe, and utilising that frozen water to keep our astronauts alive, but also to convert that water into hydrogen and oxygen, which is our rocket fuel. So perhaps that could get our astronauts back off the surface and return them home to Earth, or even sending missions onwards to Mars. So there is a lot going on, and so yeah, keep an eye on future missions, even starting as soon as next year, in fact. Now there is so much more that you can explore with this program, and I could spend hours going over it. But what I would suggest is if you scroll down to the bottom of the screen, and there's a question mark, and if you click on that and go to Lunar Examples, it will take you to another link here. And the team have spent some time showing you lots of different things that you can explore. Even just straight away here, explore Apollo 12. You can see this phenomenal image here taken at the Apollo 12 landing site. You can also chase the satellite. So this is quite a nice little demo. Quite easy. You can see where the satellite is today, and see what it's flying over and what it's taking images of. And there's just so much more you can play around with. So you could even, as a demo here, this one's slightly more complex, but you can plan your moon base. So what you do is you look at all the different the data sets and see how they combine together, and you can find places that have water, that have flat places to safely land, and multiple different scientific places of interest. And yeah, there's just plenty for you to go and explore. So I'd highly recommend if you spend some time playing around on here. Now, hopefully you've all been able to follow along at least somewhat on some of those different things that I was able to talk about today, investigating past, present, and hopefully future missions. And I hope to see you all exploring the moon from home and seeing what else you can discover.